So today I'll try to tell about Kotlin Multiplatform. I was trying to do so for 3 months, but every time there was some issue, every time different one, but here we are. Yeah, let's start. So here's a bit about what we'll be talking today. I'll tell about Kotlin itself a bit in the beginning, then about multi-platform in general, what's just a reminder what approaches we had, what struggles maybe we had with them. Then we move to Kotlin Multiplatform in general. Then we'll see how we share logic and UI if we want, and what we can share, what we can not. And then we'll see some code, and after that, there is another section with Q&A, which I forgot to add here. But anyway, so start with Kotlin. You probably know it's made by Google. It started in 2011, and somehow the version 1 was only available in 5 years in 2016. I believe it started as a desire to replace Java to fix many issues it had, like null pointer exceptions we all love and cherish, and other inconveniences. Additionally, there was this problem that because of legal issues in Android specifically, we stuck with Java 8. Yeah, and it wasn't cool even in 2016, I think, because yeah, it's an ancient one. I didn't fact check when it was released, but pretty much was around that time, if not earlier. Yeah, and in my personal opinion, Kotlin is something that's helped keep Java, if not alive, but slightly less dead in terms of it's another JVM-based language after all, so all the infrastructure built is still relevant. So yeah, there's still a point to develop for JVM and use less awful languages. Well, love Java, but anyway. Then about multi-platform. Looks like there was this desire to share logic between platforms all the time. And to the time, there were different approaches. I think the oldest one was modules written in C++ and compiled to exact platforms. I believe Dropbox was doing a lot of it back in the days. I don't know how it goes now, but I doubt it's something you can teach that quickly. Yeah, there are many good reasons why you want to use C++ modules, such as performance and the fact that they can be compiled to pretty much any target, but the price of sanity is quite high. There were attempts, well, still attempts to share UI, and initially, I believe there were mainly web-based solutions. They're still around, and even though the web is a great medium, somehow off on mobile phones, in my opinion. Then React Native and Flutter came with different approach. You get native apps in the end. You just use different common language to express what you want to see and how it should work. And the recent development would be Kotlin Multiplatform and Compose Multiplatform. First is to share mainly business logic between apps, and the second is UI. I'll talk briefly about it later. Well, to be exactly fair, there is another more recent thing for multi-platform that made not from Android towards iOS, but the other way around. But maybe we can talk about it some other time. Now, if we talk about Kotlin Multiplatform, there are some main concepts we should speak. Basically, you have shared code and platform-specific code. A lot of them built around expect and action mechanism that means that in the shared code, you can declare a function, variable, object, class, whatever, with expect keyword, and then it will make you implement it somehow for each target you declared in your project. So yeah, there will be specific implementation for Android, for iOS, for web, for desktop, for well, whatever target you have. And you'll be able to use it in the shared code as if it was there in the first place, obviously. Since it came from JVM world in the first place, everything is built with Gradle by default. Probably you can use different build tools, but that's the default one. At the moment, you can use mobile, desktop, and web targets. They can be more granular underneath, as you can see in the screenshot to the right. For instance, if we go all the way down from native to Apple to iOS, you can stop at iOS, say level, and have implementation there, but you might as well go lower to particular architectures, as well as go up to Apple level, which will target all Apple infrastructure, if it makes sense for you. Yeah, and obviously, pretty much everything can be written just in Kotlin, from config scripts to native API calls and stuff like that. So the next part is shared code. Yeah, here shown how it is delivered for each platform. There is no surprises here, to be honest. For iOS, it will be either framework or CocoaPod dependency. Pretty much the same way you'll add any third-party dependency. To be honest, the same applies to all other platforms, just for oral information. It will be Android archive, Java archive, npm package, or plain JavaScript file, and different assortment of static or dynamic libraries for native targets. Then we come to platform-specific code. Here I'll talk about it for Android iOS examples only, but for any other JVM target, native or web, it will be somewhat similar. So I'm not exactly sure it's the right way to separate it like this, but I decided to go with platform-specific code and platform-native code. Bear with me, I'll explain what it means. Basically, in both cases, this is some implementation that makes sense for a particular platform only, but in first case, with platform-specific code, you can still use Kotlin in different ways, but it will be targeted for this particular platform, for iOS, for instance. Mainly, well, I'm saying mainly, but I can think of any other option. It's, for instance, for iOS, it's done through C-interop, which is a way to generate wrappers around native APIs, C APIs. So you can interact with them through Kotlin code. It's wordy, awkward a bit, and experimental still, but it works. I used it several times and didn't have any issues with it so far. If you absolutely need to go to like native code, you can do it as well. For Android, well, there is no difference at any level. It will be Android main directory with Kotlin and Java, but for iOS it's Swift and Objective-C. Yeah, you can see a structure of a simple app that targets Android and iOS to the right. The common main is the place where all the shared code will live. Then we have Android main, which is pretty much just Android app. Then iOS main, it will be where that platform-specific code resides, still in Kotlin. And then there is a separate iOS application where absolutely completely native iOS project will live again. It will look similarly with different targets, but it will be a massive tree, so I decided not to include it. Yeah, that's pretty much a super brief overview of the structure and features. Let's say, and I decided to give 2 examples of some like exact feature you can implement in different ways. So the first one, which I was doing a couple of days ago, is audio player example. It was a Compose Multiplatform project, so you can share the one where you can share UI as well. And I need to have a obviously audio player for Android iOS. And one way to implement it is through platform-specific code. You basically define some common interface in the shared code, then implement it a normal way in Android, just like in a basic Android app. And then for iOS, you can use mentioned Synterop to interact with native APIs. One thing to note here is that all these Synterop bindings are generated. So that means that technically you can do the same with any native code you have. Like, for instance, you have some third-party library, some already created native implementation in iOS app, and potentially you can generate the same bindings and use them from this platform-specific Kotlin module in the same way. There are some difficulties, well, not difficulties, but more like specifics, because you dealing with wrappers, but still on top of C APIs, you need to care about pointers, memory allocations, scopes, and stuff like that. There are a lot of helpers for that, but that's something you'll need to keep in mind. Yeah, and then you provide these implementations through dependency injection or however you like otherwise. Another option is through from native code. It was a image converter. Similar thing, have a common interface. You implement it natively for each platform and provide through dependency injection. The setup will be, as you can probably imagine, more difficult. Dependency injection part, but not too awful. One possible problem, not like problem, but difficulty, is that you'll for sure meet with incompatible types. For instance, with this image converter, I needed to make this helper function that convert byte array to NS data NS data is quite ancient data structure in iOS, and it's all over the place. You struggle with it less from Swift, but still. It comes from old days of iOS. This NS prefix comes from next step, I guess, and the NS string, NS date, NS number, all the sort of things. And they're not often too pleasant to work with. Often they may be based on string keys and nasty stuff sometimes. Yeah, and as you can see, there is this example of specific things like usePinned and memscope. They are they're here to address differences between how C works and how JVM-based languages works. Basically, when you use, I might be wrong a bit, but when you use usePinned, it temporarily stops garbage collector, so it doesn't move around Kotlin object you're working with here until it's finished. Something like that. So I was talking about different options, how you can implement, and I thought it will be interesting to see C-interop compared to just Objective-C and Swift implementations. These three examples are absolutely identical. They do the same thing, and you can compare the amount of stuff you need to deal with in each case. Also, it kind of proves that the API will be using more close to Objective-C than Swift, because it's clearly the trace function calls more similar to this one than to this one. But yeah, it's absolutely doable. But as I said, it's still experimental, whatever it means. So probably mean mainly that it can be changed in the future, and maybe it's not that stable. But again, I've never experienced any problem with that so far. And I can guess that it will be more troublesome to debug. I'll have to look at that. Another thing is worth mentioning is Compose Multiplatform. Since we're talking about Kotlin, it's again made by JetBrains. It's based on the Jetpack Compose, which is a UI framework, mainly UI framework for Android, similar to Swift UI in iOS, and frankly speaking, to React conceptually. When I was saying that's mainly UI framework, it's because the part that actually layouts and render stuff, or like render stuff, is decoupled from the compiler itself. So potentially you can use Compose compiler for different applications. For instance, I know there are projects that use it for business logic. I don't remember the name, but yeah. And probably that's why it was so, well, I can't say easy because I personally don't know, but it looks like it was at least possible to make Compose Multiplatform on top of that. And at this time, it works with iOS, with web, and with desktop targets as well. All of them are in different stage of experimentalness. Let's say with the web one to be the most cutting edge, I would say. It's based on WebAssembly, I think. And yeah, the thing I was a bit disappointed about Compose Multiplatform is that while it's native app in the end, on iOS and other targets but Android, it will be just a canvas with stuff drawn on from the ground up on it. It doesn't use any building blocks you'd expect in native platforms. So all the view system for all iOS will not be utilized here. It's basically what Flutter does, but at least for Android, it's absolutely pure and native. Arguably, if you start Android app right now, it might make sense to start from Compose Multiplatform because for one thing, there is almost no difference, at least I'm not aware of any significant differences for just Android app. But at the same time, it will be easier to support different other platforms from this point onwards if you ever want. Let's face it, you'll want. Yeah, that's it. And here's some pitfalls and hopes of this technology, let's say. Yeah, the main part is that it's still relatively new. Many parts of it is in alpha, beta, or experimental stage. Any modern and relatively big project that use Kotlin Multiplatform or Compose Multiplatform will be littered with experimental something annotations like everywhere. But again, I'm not sure that's a problem. Yeah, project structure might be overwhelming at first because it's like several good old Java enterprise grade projects crammed together. It's a lot. Gradle can be complicated, especially if you're not used to it, which you probably will not be unless you worked with Android before. And if we touch Compose Multiplatform, there are still a lot of trivial things that are not exactly solved, unlike with React Native and Flutter. Yeah, as I mentioned here, my latest what the fuck was keyboard avoidance in iOS. Like if you have some text input at the bottom of the screen and you open the keyboard, it will cover it by default. That's partly because it works differently on iOS and Android. On Android, when you open keyboard, it will actually shrink the screen, the app windows, better say. But on iOS, it draws on top of that by default. There are machinery to handle that in iOS world, but it's not migrated to Compose Multiplatform. You need to reinvent it. It's not a complicated task. You basically listen to keyboards appear on the screen and update some paddings, but still. Yeah, the good part is that for a year, I think already, Google considers Kotlin Multiplatform a go-to solution for building apps and supports it a lot, which means they are slowly migrating a lot of libraries they have to support Kotlin Multiplatform and Compose Multiplatform, which is a big deal because a lot of them, and Google's a big company to support them and deprecate, but we don't talk about that. And the good part, another good part, in my opinion, it's easier to implement missed parts natively with Kotlin Multiplatform than with React Native or Flutter. For one thing, because with React Native, you basically have 3 separate apps. You have Android, you have iOS, and React Native on top of that. That's why it's all together. But if we speak about Android and iOS case in Kotlin Multiplatform, you have normal Android app and a wrapper for iOS. So instead of 3, and yeah, it's not bad. Same for Flutter as for React Native. Another good part is that it doesn't force you to share anything potentially. If you have two applications at this point, like a fully native Android, fully native iOS app, and you want to migrate it to Kotlin Multiplatform, first thing you can do is to initialize a project and put all your Android app in the Android directory, iOS to iOS, and tweak build phase a bit and share no code in the beginning, and will build just fine. And you, from that point, can slowly remove specific codes to shared models and gradually do it over, which is not a bad part. Which actually means that if something goes wrong, you can do it in reverse. You always have a way to just back off and use native implementations all the way, and not being stuck with complicated machinery brought with React Native or Flutter. Yeah, that's pretty much it. I don't think I forget something, so let's call it a day. And yeah, let's say questions section. I'll probably stop sharing because I don't see people. So.
I have a question about shared UI. So does it literally look the same on different platforms like web and iOS and Android? Does it really look the same, or it tries to look the same?
It looks the same, but there is a workaround around it. Workaround, can I say it? Yeah, the same as with Flutter. When you start Flutter app, you can either use Material Design app or Cupertino UI. There is a project that implements iOS-like UI elements in Compose Multiplatform, but by default, it will look like Material Design everywhere. And there is another project that can help you switch between these platform-specific components easier. And another part to mention here is that the Compose itself builds so that it's easy to build design systems with that. So, for instance, you have let's say text input that looks like material design text input, but underneath it's a component called, if I remember correctly, base text input 2 for some reason 2, which implements everything but UI. So all the interactions, all accessibility and stuff like that. So you can easily build your design system on top of lower level 1 and don't care about material design at all. Which is probably something that will happen in any case in pretty much any real application. You'll have a design system. So yeah.
By the way, does it allow using HTML when it comes to JavaScript development? I mean, can I use CSS and like HTML code?
I didn't check web in terms of Compose Multiplatform too much, but I think you can, in any case, you can still back off a bit and use just shared logic and implement web parts, web UI, however you like. It will basically give you a JS bundle or whatever it will be that you can include in whatever environment you want, like a npm dependency or project to your React project. All the logic will be there. I don't know also how well it works with in terms of optimizations and bundle shrinking with such approach. I have a feeling that's not that well, but yeah. That's probably the price you'll pay, but maybe it's okay.
How do you think, that's just a funny question, but is it possible to compile a Flutter app using Kotlin Multiplatform? Just in case.
Well, Flutter app is basically rendered. If we talk about Android OS, it will be it will be some place in your native app where it will be rendered, like with React and your index page. So like there's a place where it will be rendered. So technically, you can render that Flutter piece in any other place you want. So up to the point that you can have a separate screen where Flutter app can be rendered. Just that. That's actually how it happens in different apps. I'm not sure about Flutter, but some applications that use React Native may use it for just a part of the app. You have like separate native screens, and then at some point, React Native root will be mounted at that screen, and from that point, you'll have some user flow that implements in React Native, and the rest is native, something like that. So probably same with Flutter.
How do you think why there are so many approaches in mobile world? Because you have React Native, Flutter, now Kotlin. Why are they fighting that hard with each other?
Same reason why you guys have so many JS frameworks.
Not so many, like
but less
nowadays.
There's always a person who's seen that other implementation sucks, and he went crazy and built another one. So, yeah, go.
Can you hear me?
Yeah.
Yeah, for sure. I have a question. How does the end result works on the platform that doesn't have JVM? Does binaries
it most likely will
get
be
shipped with virtual machine?
It will be compiled as long as that platform support it. For instance, it will be compiled to whatever native binary it expects. It doesn't mean that every supported platform will run some version of JVM just to render all this stuff or to execute.
No JVM is running on Linux or on iOS for my application.
No, for iOS, no. It will be, as I said, either static or dynamic framework or Compose, and inside it, it's like a normal binary that's normal for iOS. As for Linux, I don't know, because technically it can be JVM target. So probably in case of Linux, it will be as if you have some like Java application. I think it can be done differently, but I'm just not sure about Linux. For instance, for macOS, it's definitely not JVM. But for Linux, it's a bit more gray zone to me.
On iOS, if it's not JVM, how do they manage lack of JVM functions like garbage collector, multi-threading? I don't know what else. How do they do this? Do they do cross?
There is a project called Kotlin Native, which lets you compile your Kotlin code to whatever native implementation you need. Something
Do you
like
mean
that.
the code gets compiled to another code? which then gets compiled by.
I honestly don't know how, if it's you mean if it's like compiled.
Yeah, Kotlin, then Objective-C, and then
transpiled to some C. That I would guess the latter. I'm pretty sure it's done through C, and then it compiled to exact target. But I'm not sure about. I can research it and share, but yeah.
I'm very curious how it can be compiled or converted to C, because in JVM you do garbage collection in runtime, but unless you implement some kind of virtual machine or garbage collector and ship it with your application, it won't be possible, as far as I know, to do this one-to-one compilation or installation.
I think that's fine. I can remember, but probably you can't do system calls in Java because Java is a very strict language, and you can't call to native functions like garbage collector. You basically can't control it. Java is very limited with such abilities. So, yeah, probably this is how it works.
Yeah, I'm looking up right now, but yeah, it says that first Kotlin code will be translated into some intermediate representation. So probably can think of bytecode, more or less. Then it will convert it to low-level virtual machine internal representation, and this code got somehow optimized. What else? Then LLVM generate machine code specifically for target architecture, some linking phase, and reduced final binary, something like that. I didn't have time to go deeper at this moment, but I can do it later.
Is there? It probably means that there will be some overhead on top of our code, right? To run garbage collection or to
yeah, pretty much. I'm sure there will
to
be
do something that. Okay. Thank you.
Sorry, I needed to answer the call, and when I'm back, I see that everybody is silent, and I'm not sure what's going on. Okay, have we done? Or
yeah.
Okay. So thank you everyone who joined today, and
Yeah. One note. I went to Kotlin Native page in documentation. It says that Kotlin Native blah 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 compiles Kotlin code to native binaries which can run without a virtual machine. So somehow it works without virtual machine there.
I think they just add, for example, garbage collector as a just bundle it with your code and it runs as a separate thread, or maybe other abstractions that allow us to run code in parallel, but I think it should be there.
Yeah, I'll definitely try to dive deeper into it and share what I found. Yeah.
Okay, doesn't mean that we are surely finished. Yeah. Thank you everyone who's joined. Thank you, Pavel, and see you guys. Goodbye.
Thank you. Bye.
Thank you. Bye-bye.
Bye.
Thank you. Bye.